Okay, this is the P3 paper from June 2021. Question number 2, as we can see by looking at it, it's a trig addition formulae question. We've got some double angle formulae in there. We're trying to prove this identity. Later on, we're going to be solving a trig equation. So let's have a look at it. The first part says, can we prove this identity here, part A, that 1 minus cos 2x all over 2 sine 2x is identical to k tan x. And what we're going to need to do, obviously, is work out what k is. So, yeah, absolutely. We'll start with the left-hand side, which is 1 minus cos 2x over 2 sine 2x, and as I said just a minute ago, we can see we've got a double angle there and a double angle there. With the sine 2x, I don't have a choice, that's just 2 sine x cos x, but cos 2x here, cos 2x can be cos squared x minus sine squared x, but we hardly ever use that because we've got coses and sines in there, so it hasn't really simplified to what we might want. The other two choices are 2 cos squared x minus 1 or 1 minus 2 sine squared x. And I'm going to choose the 1 minus 2 sine squared. I'm going to choose that one because then I'll be getting 1 minus all of that. And then the ones will cancel. 1 minus 1 means that they cancel. So that's the reason that I'm choosing to have my 1 minus 2 sine squared x in here. So the next line down I'm going to do is to say this is 1 minus 2 sine squared x all over 2 lots of, we don't have a choice with sine 2x. Sine 2x is 2 sine x cos x. Okay, we don't need all this stuff on the left-hand side. Let's just get rid of that. And then that tidies up. What does it tidy up to? 1 minus 2 sine squared is 2 sine squared x over 4 sine x cos x. You could jump straight to the answer here, but I'm just going to put an extra step in. Not absolutely certain that I need this. Well, certainly, first of all, that's a half, 2 over 4. But sine x all over sine x cos x, simply because then they cancel and I get half tan x. So I think it's worth just putting that extra step in just to make absolutely certain to the examiner. So I've done the first part and I've shown that k is equal to a half. What does the second part say then? The second part says, can we solve this equation? Theta less than 90, or rather between 0 and 90, that's for the last part of the answer. But we can see here then, really quite standard, that bit there, not including the 9, is a similar format to that bit there. So 1 minus cos 2x, 2 sine 2x, and then 1 minus cos 2 theta, 2 sine 2 theta. So when it says hence, it really does mean using the first part. So part B, we're trying to show 9 lots of 1 minus cos 2 theta over 2 sine 2 theta is equal to 2 sec squared theta, and I'm basically going to replace all of that bit by 9 a half tan theta is equal to 2 sec squared theta, which is 9 over 2 tan theta equals 2 sec squared theta. And then what I always say, sorry, that's my alarm. What I always say at this stage of a question is, with regards to the trig identities, as a minimum, I would expect you to know, certainly with the squared ones, that tan squared and sec squared are related. Cot squared and cosec squared are related. And obviously, I would expect you to know sine squared plus cos squared equals 1. Then you can always look things up in a formula booklet, but you need to at least have that basic idea. So when I'm doing this, I'm not worried now, because this sec squared theta, I'm just going to replace that by 1 plus tan squared. We've done enough of these questions, then you should have no issues doing that. Right, this is going to tidy up to a quadratic now. So multiply everything by 2. We're going to get 9 tan theta is equal to 4 lots of 1 plus tan squared theta. Multiply all that out and tidy it up. I'm going to do all that in one go here. It's 4 tan squared theta minus 9 tan theta plus 4 equals 0. Now always have a go at seeing whether this is going to factorise. You know, the examiners have set this up, so they might set it up so it does factorise out. In this case, I don't think this one particularly does, so I just use the quadratic formula on it. Quadratic formula, x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So in other words, tan theta is going to be equal to minus minus 9 is 9, plus or minus the square root of minus 9 squared minus 4 lots of, and a and c is 4 and 4 again there, all over 2a, so all over 2 lots of 4. That all works out to be, I'm not going to spend ages doing this now, this works out to be 9 plus or minus root 17 over 8, and then inverse tan on the calculator works out to be 31.4 degrees, and it works out to be 58.6 degrees. Those are the two solutions that are between 0 and 90 degrees. If you want help on solving those sorts of trig equations, go to another part of the channel. I'm not going to do that in a P3 paper. I just take it that you can understand that bit. But if you don't, go back and have a little look on the channel, search for it. Okay, hopefully that all makes sense.